Hello, this is Professor Gayatri Kulkarni, working as an assistant professor in Mechanical Department, JSPM's Imperial College of Engineering, Wagholi, Pune. As a part of curriculum of International FDP on Environment and Sustainability, I am preparing this video. In week 1, I have prepared the video on effect of gearbox design on environmental sustainability. In that we have seen that how the reliability based optimized design is helping to improve the sustainability of environment. Then in the succession of that, in week 2, we have prepared the video on effect of conveyor systems on environmental sustainability. In that we have seen that mostly the belt conveyors we use are made up of rubber, which is non-recyclable and it do not get degraded. So there also we use the optimization method and change of material method and find out how the sustainability can be achieved. Now in addition to that, I am preparing the video number 3, which concentrates on carbon footprint. After going through this video, students will calculate carbon content or footprint. Then they will evaluate effect of CO2 emission on environmental sustainability, and they will create green solutions to air, land and water pollution. Here I have enlisted some of the ISO standards which are applicable to the mechanical related industries. ISO 20400, which is used for sustainable procurement. ISO 6880 is used for machinery for agriculture. ISO 26000 is guidance on social responsibility. ISO 14046 is for audit of water footprint, where we are calculating the amount of water used for making a product or to run a process. ISO 50001 is auditing the energy management. ISO 14001 environmental management system. TS 14001 carbon footprint of product, that means how much carbon is emitting by that particular product. ISO 10987 is used for checking the sustainability of earth moving machineries, and ISO 30000 is used for ship recycling. Now we will see that how the carbon emission or footprint is calculated. I have taken here one case study from the Shrink, which is online carbon footprint calculator, and their tagline is, the better your footprint calculation is, the more effectively you can shrink. Calculating your carbon footprint can help you to prioritize the steps you can take to shrink it. By identifying what the biggest opportunities for reduction are, this step explains the methodology we use to calculate a person's carbon footprint for each emission sector like housing, travel, food, products and services. The calculation method used by Shrink tries to capture the full life cycle of all aspects of our personal consumption. They focus on consumption in each of our 5 major categories like housing, travel, food, products and services. In addition to that, they also estimate the share of national emission over which we don't have a control, or we have the little control, government purchases and capital investments. Let us see how we can calculate the carbon footprint. Here are the formulas. Here we can see that for different parts of household requirements, how much carbon is getting emitted, like electricity, natural gas, fuel oil, LPG, waste and water. These we are requiring in our day-to-day life. Here you can see how much electricity we can use in kilowatt hour per year is multiplied by EF. EF is emission factor, and for the different categories there are different emission factors, and by multiplying that to complete use we can get the total CO2 emission in kg per year. Similarly, we can see it for step by steps for all the things. Combining the direct and indirect factors gives an emissions factor for the full life cycle of the fuel. Natural gas is roughly 6.6 kg CO2 per thermo or 0.22 kg per kilowatt hour, more than 85% of which arises directly from combustion. Heating oil is around 11.6 kg CO2 per US gallon or 3.1 kg CO2 per liter. LPG is 6.8 kg CO2 per US gallon or 1.8 kg CO2 per liter. Beyond energy sources, the two further components of our housing footprint we calculate are waste disposal and water use. Emissions from waste disposal are mainly the result of methane produced at landfill sites as well as transport. By calculating how much waste you produce each week and multiply it by 52, you can get your annual waste production. This is then multiplied by a carbon intensity to get your carbon footprint. Here we can see for the transportation, the different modes of transport we have considered, like vehicle, bus, metro, taxi, rail and flying. The distance in kilometer per year is calculated and multiplied by emission factor so as to get the complete emission of CO2 in kg per year. Similarly, we also can find out for our household things how much carbon is getting emitted, and we can optimize the use. Here we have taken one case study from the reference paper of Mr. Zhang and Jiang is sustainability computation. He has done that study for CNC machine tool considering energy efficient control strategies. Let us see. As an important part of industrialized society, manufacturing consumes a large amount of raw materials and energy, which motivates decision makers to tackle this problem in different manners. Process planning is an important optimization method to realize the object and energy consumption. Carbon emission or sustainability evaluation is the basis for the optimization state. Although the evaluation research has drawn a great deal of attention, most of it neglects the influence of state control of machine tools on energy consumption of machining processes. To address the above issue, a sustainability evaluation method of a process planning for single computer numerical control, that is CNC machine tool, considering energy efficient control strategies has been developed. First, 4 energy efficient control strategies of CNC machine tool are constructed to reduce their energy consumption. Second, a bi-level energy efficient decision making mechanism using random forests is established to select appropriate control strategy for different occasions. Then, 3 indicators are adopted to evaluate the sustainability of process planning under the consideration of energy efficient control strategies, and those factors are energy consumption, relative delay time, and machining costs. Finally, a pedestal part machined by a 3-axis vertical milling machine tool is used to verify the proposed method. The results show that the reduction in energy consumption considering energy efficient control strategies reaches 25%. Similarly, to have such type of sustainability in mechanical machineries, we can select the different environmental sustainability methods. Thank you.